let's discuss the concept of point mass in gravitation. A point particle is an appropriate representation of any object whenever its size, shape, and structures are irrelevant in a given context. For example, from far enough away, any finite size object will look and behave as a point-like object. In the theory of gravity, physicists often discuss a point mass, meaning a point particle with a non-zero mass and no other properties or structure. Likewise, in electromagnetism, physicists discuss a point charge, a point particle with a non-zero charge. Okay, let's make it more simpler. The point mass means in an object, 2 points of objects are going to attract with each other, like object 1 and object 2, in such a way they attract each other. Okay, let's calculate the value of G with the help of gravitational law. You can see there is a small object placed on the surface of the Earth. And according to Newton's law of gravitation, F is equal to G m1 m2 over t square. Here the force is the weight of the object, so I replace F with mg, and m1 is the mass of an object and m2 is the mass of the Earth, and the distance between them is same as the radius square, because you know that because of point mass from center of the Earth, from the center of the object. So when both masses are cancelled with each other on left and right hand, we will get G, small g, gravity is equal to gravitation times mass of the Earth divided by the radius of the Earth. In general, we can write down G is equal to capital G times mass divided by distance square. In case of radial gravitational field, remember we have to take a minus sign which will show the direction of this field. Okay, let's compare electrical forces versus gravitational forces. There are some similarities and some differences you can see on the screen. Like the formula is somehow in the same form, where there is one constant, there is two charges in electricity, and there are two masses in gravitational force, and the denominator is the radius. So what are the similarities? They are same form, they have inverse square relationship. Both equation has proportional to the product of their masses here in gravitational and charges in electrical, and both are non-contact forces, whereas there is some differences between them also. Gravitational force is only attractive force, whereas in electrical force can be either attractive or repulsive. So finally we reach to the last objective, that what is orbital motion and how it is related to Newton's laws. You know, Earth and many other bodies, including asteroids, comets, and the other planets, move around the Sun in curved paths called orbits. Generally, the orbits are elliptical or oval in shape. Because of Sun's relatively strong gravity, Earth and the other bodies constantly fall toward the Sun, but they stay far enough away from the Sun because of their forward velocity to fold around the Sun instead of into it. As a result, they keep orbiting the Sun and never crash to its surface. The motion of the Earth and other bodies around the Sun is called orbital motion. Orbital motion occurs whenever an object is moving forward and at the same time is pulled by gravity towards another object. This orbital motion is not only connected with law of gravitation, it is connected with the first law, second law, and third law as well. Thank you very much for watching and listening. Goodbye.